All right, hey, good morning, Shaw Connect kids. Here, we're getting ready for science. You can see all the kids have their equipment on the desk. Some of them are waving to you. This is 6W. Our first experiment today involves a piece of wax paper and an eyedropper filled with colored water, as you can see right here on Gwen's desk. So I'm going to have the kids take the eyedropper of colored water in just a moment, and they're going to drop about 30 separate drops on their waxed paper. And then what they're going to do is they're going to try to connect the drops lightly with their toothpicks. Okay, I'm going to pause you. Okay, the kids are dropping their water onto the wax paper. They're using all the water in the eyedropper, and then they're going to start connecting them. Okay, now the kids are going to take their toothpick and going to try to start connecting the dots. And they're going to find some interesting stuff here.
It's going to turn into one big one. This is so amazing. All right, ready?
This is one of my all-time favorite things to do in the world. This is so fun.
It's like a tractor at home. It's like they're just.
This is a visual representation of me at a buffet.
Okay, guys, another thing you can try is you can try lifting your wax paper and tipping it to make them run together. Try that. That's kind of fun too.
I'm gonna back up and I'm gonna drop.
Okay, Shaw Connect. So the purpose of this in class is to say that water molecules love each other. They love each other. So water molecules want to be together so much. They're a very cohesive group. Like we in the class are cohesive. We like to be together, right? Water molecules, they love to be together. Do you see how easily those water molecules, those water droplets came together? They love it. Now to show you how much they love being together instead of the opposite, I want you to take your toothpick and try to separate the water droplets now.
It's not possible.
Hey gang, we're back. So they had fun with that. They threw away their equipment. Now the next thing we're going to do is learn how to say cohesion together. I want you to say it like this. Cohesion.
Cohesion.
Water molecules love each other. They love to be together, so they say that they have cohesion. We're going to see another example of cohesion right now. Take your penny, please. Put your penny somewhere on your white tray. Remove your pin and your paper clip. You don't want those to get wet. You do not want your paper clip and your pin to get wet. So take them off and put them in a dry spot.
Not the nail.
It's the nail.
And yes.
Do we get this got wet?
That's what the pin is.
All right, gang. So what they have done now is they have filled up their eyedroppers with water. Your task to see how much water molecules love each other is to drop water droplets, not yet please, on your penny one at a time and count them. See how many you can put on that penny before the water surface breaks and the water falls off your penny. Go ahead, start putting drops on and counting them out loud. Okay, everybody stop for a minute. Look at your penny. You will notice that there, if you bring your eyes down, you will notice that there is like a cave over the top of your penny. There's like a surface. What's holding that together? Why isn't it flattening out? What property of water is holding it together? Say it. Cohesion. Those molecules are sticking together. Keep going. All right, boys and girls. So we had kids anywhere between 30, 40, 50, 60 drops before the water surface broke. The water surface stays together because water molecules like to stay together because of what property, everybody? Cohesion. Okay, now we are going to look at something called adhesion. Well, this is also a bit of cohesion as well. I'd like you to put down your water droplet, your water dropper. You're going to try to float your paper clip and then your pin on the surface of the water. Don't start yet. This takes real skill. It's very difficult to do. Paper clip and pin, try to float them on the surface of the water. If the water surface is nice and tight and still, you may be able to do it because of the cohesion of water. Go ahead and try. So this person's got it here, a pin and the paper clip are floating in the water. Cool. Okay, so guys, the next thing we're going to look at is pH. And we know from the river thing, it's a measure of whether something is acid or basic. And so I am going to give you all a piece of p-hydrogen paper, and you're quickly going to dip in, and you're going to see what color it is. and just put it on your desk. Okay, so let me do that right now. Okay, everybody has their pea hydrated paper. Do you think that the pure water, what do you think the pH level of pure water would be? About what? About 7, somewhere in the middle, right? It's acid near 1, it's basic near 14. So about 7. So when I say go, you're going to dip it and take it out. Ready? 1, 2, 3, dip. Take it out. What color do we have there?
Yellow.
Yellow.
Yeah, sort of yellow.
I'm getting kind of like a green.
Hold, yeah.
Maybe yellow.
Definitely yellow.
Hold it a little longer. And now take it out. Is anyone getting it? A little green? Okay. Okay, it looks like everybody's turned just the color that would be a 7, which is kind of like a yellowish green kind of color. Now what I'm going to have everybody do in a moment is I'm going to have them all blow bubbles in their water for a full minute, because you breathe out what gas, everybody? Carbon dioxide, which is an acid. We're going to see if we can raise the pH level, lower the pH level of our water by making it more acidic. So when I say go, you're going to start to blow into your water non-stop. Take a breath if you have to. Ready, begin. Okay, they're still blowing. I'm about to tell them to stop, and stop. Quickly, go ahead and dip your second piece in the water. Hold it in there for about 10 seconds. Or 5 seconds. 5, 4, 3, 2, 1. Take it out and watch if they're seeing what the color is going to be.
It's gonna be
It's
yellow.
still yellow. It's still the same color. It's changing.
Okay, gang, here's what we found out. That the second time we put in the pea hydrant paper, the pH paper, it did not turn as green. It's oranger. So let's look here at Addison's colors. Her first one was green. That was a neutral color. Her second one is orange, and I will show you on here that that is now a 6 or a 5 or a 6 on the acidic pH scale. So you guys just made your water more acidic. Very good.
Mine's green.
I have one more activity to show you. It's a demonstration while you guys clean up. All right, for my final demonstration, we're going to look at adhesion, water clinging to things, because the droplets like to stay together. I'm going to fill this container, this jar, with water. And I'm going to put on this lid, and this lid has a screen on it. So if I pour it out, what's going to happen?
Nothing.
It's going to dump out, right? Okay. I'm going to do it again.
I thought nothing.
Science, right, pretty obvious.
I thought nothing was gonna happen.
Pretty obvious. But let's try this.
Same Titan.
Oh yeah, I've never done that.
All right. So what I'm going to do now is I'm going to pull this paper away.
Magician.
Oh
She's
my
not a
God.
magician. It's science.
I'm not
Matthew.
doing it. So I'm saying magician.
Sorcery.
It's about
Yes.
waterfall.
Declan, do you trust me, Declan?
Oh.
I trust you.
Why is the water staying in the container?
Because it wants to stay together.
No.
Because water is hydrophilic. It loves each other. It loves, the molecules love each other. It's actually, there's cohesion between the water molecules, but it's actually adhering to the screen. Adhesion. If I tip this thing a little bit, just a little, out it comes. All right, there we go.
Do you trust me?
There we go.